Well, hi, I really appreciate this certificate of appreciation. And I chose to talk today about some of the trends in the technology and data tools that have happened since the early days of my career, starting in about 1981. It's already 40 years. So in 1982, I was hired by the Illinois Natural History Survey to work with this new technology called GIS. They thought it might be appropriate to do analysis of multiple map features, and it was an experiment for them. They hired scientists for this GIS rather than computer people. ESRI was hired to help us get started at the Illinois Natural History Survey, and we became the 12th client, and we learned on ArcInfo 2.1. The ESRI president, Jack Dangerman, he would take us on little trips during breaks to the orange orchard on the property to pick a few oranges. And this property, of course, is now full of buildings. Subsequently, Illinois was the first state with a full integrated vector GIS at 1 to 500,000 scale. And prior to this time, most of the GIS work was performed with raster processing, and they used paper printouts with different symbols for different classes within the matrix. And so they often plaster an entire wall with these printouts to get an overall view of some of the study areas. It was amazing, but it worked. It didn't have huge study areas, however. Now, ArcInfo 2.1 was vector, but the hardware and software that we had available was very limited in power at that time in the early 1980s. For data, we had a statewide digitized map of the pre-European colonization or the pre-European settlement vegetation and the land use data from the US Geological Survey, which was vintage about late 1970s. So these were digitized by ESRI for us and integrated together. And then with these, we could assess long-term vegetation changes and the attributes related to these landscapes. So I have some papers on that. At that time, a simple overlay process could run all night. In fact, my colleagues forbade me to run these overlay batch jobs during the day because we had a shared computer system, and this computer system filled an entire room pretty much, but it would slow to a crawl or a crash with more than just a few jobs running at the same time. So I had to do my jobs mostly overnight. I divided the state into many chunks then it could, because the software couldn't handle so many arcs. Other characteristics of that time include, an absence of any disk larger than about 300 megabytes. I remember our 300 megabyte disk drives were about the size of a washing machine. And that, we thought those were pretty big at the time. 9-track tapes were the main means of data dispersal and backup. There was no internet, no email. And then with remote sensing, there was no SPOT, MODIS, radar, or any other satellite other than Landsat MSS with an 80-meter resolution. And then the beginning of an experimental phase of Landsat TM and AVHR, which is the Advanced Very High Resolution Radiometer. So I was privileged to be an early NASA principal investigator to assess some spatial trends with forest plot data and thematic mapper 30-meter data, which were then used to calibrate 1 kilometer AVHRR data that we could then use to extrapolate forest cover and productivity over larger areas like the size of a state. But that was pretty progressive action using 3 levels of data and overlaying them. Most times I could only analyze about 512 by 512 pixels at a time. And so these were just used as samples for the extrapolation that we used. With respect to GPS, civilian GPS units first became available to the non-military people in the late 1980s. And there were a few satellites and a few base stations, but very, very few. So we only had a few hours of sufficient satellites up in the sky per day. And we had to do this differential post-processing from a station which located more than 200 kilometers away. So the data were not that accurate. And then with selective availability, the data were automatically scrambled by the Department of Defense, where the data from the satellites were scrambled to a rather coarse resolution of about, I think, 70 meters. And that was the norm until May of 2000. So you had to do post-processing to get any closer than that. Spatially explicit simulation models began to emerge in the later 1980s as well. There were some habitat suitability models before that, but as far as simulation, computer simulations, they started in the later 80s. So we have indeed come a long ways in developing the toolbox for landscape ecology studies. And I've been so fortunate to be a part of this fast trajectory over the past 4 decades. I know these technologies will continue to develop in the future, and we are indeed in exciting times for the landscape ecology field and for the landscape ecologists per se. However, these are also very trying times for our globe, as we all know, and landscape ecologists have a pivotal role to play in helping the entire world move into a more sustainable and enduring planet. So I want to wish you all the best in these endeavors as we work into the future to help solve some of these issues. And again, I really appreciate the opportunity to be here and to get this award from IUFRO. I appreciate that. Thank you.